Hey everyone, how's it going? My name's James. I run developer advocacy at Timescale. And today we're going to be talking about time series data. So if you're wandering past, then come and take a seat and we'll get right into it. Actually, before we start, can I get a show of hands for people that use Postgres already? Cool, a few show of hands. Our CEO uses Postgres, that's great. And can I get a show of hands for people who are interested in time series data? Cool, that's a pretty good overlap. I'm pretty happy with that. So as we start, I'm going to throw up these 4 pictures in blue boxes, and I'm going to invite people to try and work out what the similarity between these 4 pictures might be. We've got some cryptocurrencies, so we've got Bitcoin, Ethereum, and Litecoin. We've got a graph of the weekly COVID-19 hospitalization rate. We've got a car. I think the point here is that it's a Tesla, so it's a self-driving car. And we've got AWS CloudWatch, the new AWS CloudWatch logo. Does anyone want to take a guess from the audience what the similarity between these pictures might be? No one's very chatty. So the similarity between the pictures is that they're all driven by time series data. And I suppose the clue was in the name of the talk, which also involves time series data, and the name of our company, Timescale, which has got the word time in it. So when we're talking about cryptocurrency, we're talking about a distributed ledger. Each transaction is time-stamped, so it's got a time associated with it. When we're talking about this graph of COVID-19 hospitalization rates, which is rolled up by week, or I think by month there, each individual hospitalization has a timestamp on it. We're talking about a Tesla, so we're talking about a self-driving car. It's got a number of sensors on the car. Each sensor gets a reading. Each reading has a timestamp, and then it uses that data to work out what's happening on the road and how it can help you drive. And when we're talking about AWS CloudWatch, we're talking about an observability solution that collects your metrics, collects your logs, and each individual metric and individual log has a timestamp. So all of these things are driven by time series data. They're made possible because they're analyzing time series data and storing time series data. And I suppose the point is that time series data is everywhere. It's across every industry, it's across every vertical, it's in every business. In fact, time series data is almost definitely in your business, whether you know it or not. So time series data is analyzing, or when we're using time series data, we're analyzing the change in these time series events over time to be able to make decisions based on that data. And that's because change is constant. So everything's changing in our world. Change is happening faster and faster within our businesses. And as things change, we need to be able to analyze that change. And when we're looking at time series data, we can use the time series at one point, and we can use a time series at another point to analyze the change in data. But time series data is unique and challenging. So it's often not a great fit for a relational database. Time series data isn't like our typical business data that we use day to day. So it often arrives in time order. So when we're analyzing time series data, we'll get a stream of data coming in, and it usually arrives in time order. So we don't skip back in the time stream and get old reads. We'll just be getting data coming in as it's been recorded. And as it's being streamed in, it's relentless. So we might be talking about gigabytes of data. We might be talking about terabytes of data. We might have even been talking about petabytes of data that we're storing in our time series workload. When we're collecting time series data, it's mostly inserts. So we're not going back and updating data. We're mainly inserting new data. So as an example, if we were collecting weather data, we're not going to go back and update the weather value from last week to be 22 degrees instead of 21. Sorry, I'm speaking in centigrade. We're going to be inserting new data for the weather as it is today. And when we insert that data, time is made up as part of the primary key. So when we've got the unique identifier for our record, we have time as part of that unique identifier. And that plays into the next one. So it's generally queried by time. When we're querying time series data, we really want to have a time bound or a specific time on our query. One of the worst things we can do for a time series database is to say, I want to grab all of the data in my time series database and pull it back in one big query. A, if we've got a petabyte of data, we're not really going to be able to do much with that, and B, it's going to take a long time to pull it back. In a sort of similar manner, if we were looking at perhaps observability data, we don't want to say, I want all the things this instance has done ever in the history of time. That might be a valid query sometimes, but if we're doing that often, we're going to be pulling back all of our data, perhaps 7 years if we're a financial institution or something like that, and it's going to be a lot of data to pull back. So generally, when we're doing a query, we want to say stuff like, what's this instance been doing in the last week, in the last year? So we're querying by time. So how do we store that data? I suppose the way that Timescale likes to store that data is within Postgres, which is a relational database. Timescale helps give Postgres time series superpowers. So what does that actually mean? So Timescale sits in the middle of this Venn diagram. So Timescale gives you a relational database. So it gives you everything you know and love about Postgres. It gives you everything you know and love about a relational database. It gives you the ability to use full SQL. It gives you the ability to connect to your database from any of the many integrations out there that work with Postgres. It gives you the ability to join your time series data back to your business data. It gives you the ability to use things like complex types which Postgres gives you. It gives you the ability to benefit from battle-hardened Postgres mechanisms that have existed for many years at this point. But Timescale also gives you a time series database. So Postgres plays on the features that we just talked about to make Postgres really efficient for time series workloads. So we know we're going to be ingesting a lot of data. So Timescale helps you ingest that data into Postgres in an efficient manner. It helps you query that data in an efficient manner. So what we get is a relational database that's great at a time series workload. At this point, sometimes people look at the right-hand side of this Venn diagram and say, what about time series databases that have been built specifically for time series? How do they fit into this picture? Surely they'd be better than a relational database. And I like to respond to that in 3 ways. Firstly, on the performance angle, turns out when you enhance Postgres with Timescale, it's very performant. So we've done a lot of benchmarks, and I invite you to come to our website and check out some of the benchmarks. We benchmark against relational databases, and we benchmark against time series databases. And I'll leave it up to you to come and make your own conclusions. But when we're beating dedicated time series databases on the right path by over 1,000 times, I would say we're doing something right. When we can provide a time series solution that's over 100 times cheaper than some other custom time series databases, we're doing something right. The second thing that I like to talk about is the trade-offs you have to make. Well, not that you have to make. When you're making a custom time series database, you're playing specifically to those time series features. So you don't allow out-of-order inserts. You don't allow data to be updated, because we know that that doesn't normally happen with time series data. Because Timescale is a time series database, and it's also a relational database, we can let you do those things. So you can go back and update data if you need to. You can go back and say, I want to backfill this old data if you need to. So we still use those characteristics to become faster for time series workloads, but we don't hold you to them. We're still flexible, whereas time series specific databases tend to be a lot more inflexible, and they won't let you do those kind of things. Then the third thing that I like to talk about is that when you're building a custom time series database, you often push yourself into a corner. So you often find that the performance that you're going for really limits you. Timescale Cloud is our product for Timescale. So it's a cloud product. It performs at scale. It's cost efficient, and it saves you time. So what we're doing is we're trying to hit all of these areas and providing you a product which runs on AWS, which services all of your database as a service needs, and integrates with all of your AWS services. So we integrate with CloudWatch, you can pair your VPC, and you can integrate with services like Lambda. Like if you want to stream data in from Managed Kafka, that's fine. If you want to push data in from IoT Greengrass, and you want to push data in from IoT Core, then that works really well as well. So here we've got a sort of block diagram that shows our key features. And obviously, we're not going to be able to go through all of these features today, because this is a very short talk. But I want to sort of touch on a couple of them and pull them out to talk about. So one of the first things I want to talk about is our best-in-class compression. So what you might be asking, but Postgres is a row-oriented database, and most of your competitors are columnar databases. We actually have a compression algorithm which can pull row-based data, push it into columnar data, and then get 90 to 95% compression. So you might see data that's a terabyte compressed down to 50 to 100 gigabytes. We also have a feature called continuous aggregates. So that allows you to have a query and then run that query once, get the results of that query, and then use it like an incremental materialized view. So you're updating that query over time in the background, and then you can query that in real time. So if you've got a query that's taking a long time to run, you can materialize that query and have the benefit of it running almost instantaneously. It might normally take minutes, it might normally take hours. You can get the response in milliseconds. Another feature that we're really excited about, and we actually announced as part of the AWS reInvent schedule, is mentioned down here under performance at scale. It's bottomless storage. So this is a closed beta feature at the moment, and I really encourage you to come and talk to us about it if you'd like to. What it allows you to do is tier data to Amazon S3 using the Apache Parquet format, and then query that data transparently with the same table. So when I'm querying data through my timescale hypertable, I could be hitting row-based data, I could be hitting compressed data, and I could be hitting my Apache Parquet S3 data, all within the same query transparently. So it's a real question of data lifecycle. I can decide where I want my data to be at various stages of my data lifecycle, and in fact, if I don't want my data anymore, then I can also drop that data at the end of my data lifecycle. And of course, down on the bottom right there, we've got the feature I was talking about before. It's just Postgres. So Timescale builds on Postgres. We've got an open source extension, Timescale DB, which powers our whole ecosystem. It's just an extension for Postgres. So you get to be able to query via SQL. You get rock solid stability, vibrant ecosystem, and you can interoperate with almost anything. If you're interested, I'd encourage you to go to tsbdb.co/try-timescale. You can get started today. When you sign up, you'll be able to use Timescale Cloud for free for 30 days with no credit card. Give the product a go. You can spin up as many instances as you want and really try out how Timescale works. If you're interested in the bottomless storage, which can scale out elastically, then sign up for our private beta and you can give that a go as well. Cool. That's the talk on time series data. Thank you for coming.